If there's anything at all you don't understand, just holler, raise your hand, or whatever, and shout out to me. My name is Troy, and so basically, this is kind of, I've redone these slides here. PyMC3 is a really large machine learning library with all kinds of neat stuff in it, but I had like a whole book that I was making, and so yeah, it was just too much. So what I've done is I've kind of backtracked, and I'm just showing a really fun example that was useful for me. This isn't even my own code, so this is made by a guy named Austin Rochford, who is just a wizard at PyMC3. And so at the end of this, you'll be able to see his notebook and everything else. How many, again, know that some of the room is familiar with Python, some is not. How many people are familiar with Jupyter Notebooks? Do you know what Jupyter is? Yeah, or Python. So it's basically a way where you can go and put code or descriptions, things like that, into this little web page, and you can see what it does, and it's very useful. And it lets you kind of play around with machine learning. It's really cool. I've got this notebook here on my machine, and a whole bunch of others. If we have time, we'll kind of look through, especially if you have questions. But I've got 86 slides, and I'm going to just race through these really fast, but just holler if there's anything you don't understand. All right, so this is me. I'm Troy. Basically, I started out a couple of years ago as a cloud architect, and I've been very interested in big data, and now I'm really interested in machine learning. I work for a local company called eLinks, and so what I do is I take all the algorithms that the data scientists make, and I turn them into applications on our webpage. I work with a group of C# developers as the liaison between the data science team and the C# team. And so I basically take and turn things into, from ideas and concepts into real software. And that's been a really cool niche, kind of got me into learning it, and I get to work with a lot of really fun people who are super smart, a lot smarter than I am, but I'm picking up things from them pretty good, and it's a fun job. Whoops, let me go back. So PyMC3 basically is it's a statistical package that lets you do Bayesian inference, and that sounds really like a big fancy thing, but it's not. At its heart, it's very simple, very easy to use, and I'm just going to kind of show you guys just the high level where you can use it and do a few things. And I'm going to show two examples. One is a super simple example, and the other one, as I said, is a notebook from this guy, Austin Rochford, who it kind of shows sort of what you would run into more in a more real world situation. But almost all of this is just going to be, it's going to look a little fancy and have some fancy math notation, but all of it is sort of high school algebra. So I'm just going to go through and show that. All right. So first thing, this is Bayes' theorem, which is the heart of everything, that's Bayesian inference. And there's a couple of pieces here. This is kind of a funny name. It's called the posterior, which means the thing that you get out of this once you put stuff into it. This right here is called the likelihood function. And then what you do is here you're basically putting in the probability of a class, in other words, sort of a yes-no thing, like what probability a certain thing has. That goes here. And this equation, we'll come back to it here in just a second. I want to show you what it actually looks like, because it's really simple. Basically, you set up what's called a prior, and the prior is some guess. It's basically, you think that the data is going to have a distribution that looks like something. And there's tons and tons of different distributions that we can use, and I'll show you some of them. But you feed the prior in, which is your guess at what something is, and then you provide evidence, which is just some training data. So basically, you've got a little bit of data of some kind that you've made or you've got from somewhere. So for example, let's say we do a lot of oil and gas, so maybe this is pressure data from the well or something like that. So we could have that and we say, well, based on what we know, we think it's going to look like this. And then we get this posterior curve that comes out. This shows, basically what the model that we built is supposed to look like. So let me pop back real quick to here. So this is the posterior. This is the prior, the likelihood function. Sorry, this is the prior. This is the likelihood function. So this is sort of the evidence that we give to build this. And again, this equation here is something to think about. This is kind of what generates it, but it's not the thing that actually does all. I mean, it does all the work, but you don't need to worry about it. You won't need to actually memorize this or anything to be able to use it. So, Bayes' theorem. So, a few words about priors. Basically, these are just a guess, a belief, something that you think is going to happen. And if it doesn't work that way, well, back up and run back through again and kind of retest your thoughts on that to say, well, we thought it would work this way, maybe not. And that's what the real world example is going to look like. We're going to come up with some idea of what we think it is, and if it fits, great. If not, let's kind of dig into it a little bit deeper and see what's going on. So, and posterior is basically inside of IMC3, it's going to use Bayes' theorem to calculate everything that's going on. Is that jumping?
A little, yeah.
Yeah, it's making me kind of dizzy. All right, let's keep going. So this right here is how it all works. So basically, we're going to come up with a model, which is some sort of mathematical equation that we think is going to describe it. So like pressure might be just a straight line saying, hey, we think the pressure is going to go up or going to go down, or something, something that we know about, something that we work with. So, this model, again, is processed through Bayesian inference. And then the next step we go through is actually fitting that model. So what happens is that when we get this posterior curve, we don't know if it's right or not. So how do we tell if it's right? Or how do we know that all of these points really make sense? And what IMC3 does is it's got two different algorithms that goes in here. One of them just takes samples, which is just little pieces of that posterior curve. And by taking hundreds or thousands of them, you can get an idea of whether of how close that is to what you want. And so this fitting part here will give you a curve that you can see, and it looks something like this. And you can't see it very well, but there's actually two different curves here, the green one and the orange one. So the green is the actual and the orange is the fit. And so what you're trying to do, is to get them to overlap just as much as possible. So it's pretty easy, and this is kind of how all of this is going to work. You start with some model, you fit it, and then you see what you got. Anyway, I've got a bunch of silly slides in here. Try to break it up a little bit, otherwise it just sounds like a bunch of math. But yeah, hopefully that is what I just said doesn't sound too much like this. So let's talk about model fitting. Basically, when we're fitting the model, there's, we have what's called a confidence interval, or a series of, how close we think that this is going to fit. And there's two things that IMC3 does. there's something called Markov chain Monte Carlo, so MCMC, that's where the MC comes from. The 3 doesn't mean that there's another MC, it's just this is the 3rd version of the library. So Markov chain Monte Carlo, that's a very slow method, but it's the most accurate. There's another method where it uses an algorithm called ADV that's faster, but less accurate. And so that's one of the things that always is an issue here, because PyMC3 can be really slow if you do Markov chain, which is sampling. And so we won't do any variational inference examples here, but that's something out there that does make it a lot faster. All right. And so this is the Markov chain Monte Carlo algorithm. What it does is it just makes a simulation, which means that it just takes all kinds of points inside of that posterior distribution and tries to see if they line up with what we expect. So far so good. Basic statistics. All of this is kind of hopefully meant to be just as simple as possible. And yeah, the more samples you have, the more accurate your results are going to be, but it's going to be a lot slower. So that's one thing we'll see. All right. So let me finish up here with posterior analysis. So we have 2 different tools to start off with, and these are just sort of the beginning. So if you remember earlier I showed the 3 steps. First we have a model, and then we fit the model, and then we see, does that fit look right? And that's what's called posterior analysis. So what we're doing is we have 2 tools. One is trace plot, which produces a graph that looks something like this, where it shows the distribution, and then it also shows the sample frequency. There is another thing called summary, which generates sort of a text output that you can see it. And so those are what we would use to see, did it work or not. So, all right. And so this is the whole thing. This is the amount of code that you'll have to do all of this. It's pretty simple. We'll go through this a little bit more, but this is how you set up the model. And this is how you do the fitting. And then of course here you have trace plot and summary. So super simple, I told y'all it would be. And we'll go through some examples of this, but and they'll be really, really basic, but this is the process. So really, really easy compared to it's not quite as easy as like scikit-learn or some of the other libraries out there, but pretty easy for doing Bayesian statistics. So, and by the way, the reason why I chose this was because there's a lot of places out there that either have super simple or super complicated examples, that they try to teach. One thing that's really simple I see a lot of is people who might know a little bit of Python, and then they've used some neural networking library or something like that. There's a lot of that being trained here, but neural networks are sort of a black box, and it's sort of hard to get to use that in real world applications. Neural networks are great. It's not always easy to explain why they did what they did. And so, but then full-blown statistical stuff where a PhD has to understand it, that's pretty hard for the average person to swallow. So PyMC3 is sort of in between, and I like that because it uses statistics and gets you thinking about statistics, but it's not as much of a black box as neural networks are. So this is sort of a tool for you to use if you want something that you can understand and that you can also present pretty easily and show results, at work or something. So trying to get everybody, get the community, more interested in learning more things than just neural networks to do machine learning problems. So, all right, I'm going to just fly through these. I'm going to go fast, and hopefully we'll have some examples to show you on my notebooks. So this is machine learning. Does it seem scary so far, or so far so good, pretty easy? Any questions, anything that didn't make sense, or all of it maybe? It's all basic statistics. Actually, my mentor, my last job, he taught me that most of machine learning is statistics 101. It's pretty simple. Come on here.